Hello friends, dear students, good morning to all of you. I am here, Lalit Kumar P. Bhaiya, Associate Professor, Bharati College of Engineering and Technology, Durg. Dear students, till now we have learned in the last video about H parameter model of a transistor, that is low frequency H parameter model. Today we will go through the details of the H parameter, how the H parameters are calculated for the single stage amplifier. We have seen the four types of H parameters. This is the circuit diagram, model of a transistor amplifier, and using this model we have determined the four H parameters. This is the model we have taken, two-port model of a transistor. Port 1 that is input port and port 2 that is output port. I1 and V1 are the inputs, where I2 and V2 are the outputs. I1 and V2, these two are the independent variable, where V1 and I2 are the two dependent variable. So we have written the equation for V1 and I2. We have written these equations for V1 and I2, and we have taken as these parameters H11, H12, H21, H22, where H11 is the V1 by I1, that is input port. V1 and I1 both are input port when V2 is equal to 0, that is output shorted. And H12 is the V1 by V2, that is reverse voltage gain when input is open. So H11 is nothing but HI, input impedance when output is shorted, and H12 is the reverse voltage gain when input is open. And third one is the H21. Third one is the H21, that is I2 upon I1 when output is shorted, that is forward current gain I2 upon I1. And last one is the H22, that is I2 upon V2, that is output impedance when input is open. So two parameters are found when output is shorted, and two parameters are found when input is open. So this H22 is called as HO, output conductance. H21 is called as the forward current gain, that is HF. So these four parameters are you can see here, these four parameters are H11 means HI, that is input impedance. H12 means HR, that is reverse voltage gain. And H21 means HF, that is forward current gain. And H22 means HO, that is output conductance. So these four parameters, and we can draw the equivalent diagram using this H parameter. This is the diagram where this is input V1, input current, input voltage is V1, input current is I1. This is the input impedance HI, which we have seen. And this is the voltage source at the input, that is HR into V0, VO, HR into V output voltage. And this is the output current source, HF into I1. HF is the forward current gain, HR is the reverse voltage gain, and this is HO, which is in parallel with this current source, is the output conductance. I2 is the output current and V2 is the output voltage. So this is the equivalent model of a low frequency transistor. You can replace this model in place of the transistor while analyzing the low frequency. analysis of a transistor, low frequency analysis of a transistor. That we have also seen this one for the transistor. This input voltage VB and output current IC. These are two dependent variable, and these are two independent variable IB and VC. So this is HIE into IB plus HRE into VC, and IC is equal to HFE into IB plus HFE into IB plus HOE into VC. So this is the common emitter configuration, and for common emitter configuration we can write this input voltage and output current in terms of these four parameters. Because this is common emitter, you can write in place of HI, you can write HIE. In place of HR, you can write HRE. In place of HF, you can write HFE. In place of HO, you can write HOE. So you can make the suffix for the configuration of a transistor. For common emitter, HIE, HRE, HFE, HOE. For common base, HIB, HRB, HFB, HOB. And for common collector, HIC, HRC, HFC and HOC. So these we have already seen. And this is the transfer output characteristics of a common emitter configuration. Here output current IC in milliampere, and here output current VCE, output voltage VCE in volts. So this is output characteristics, keeping this base current constant. This is for IB is equal to 0. IB1 10 microampere, IB2 20 microampere, 30, 40, 50, and you will get these characteristics. And this shows the load line here. And this red point is shown here as a Q point, operating point of a transistor selected here. So you can select any of the operating point, Q point on this load line. This is the active region. So in active region you can take anywhere. Generally at the center we select the Q point for better operation. This side, after this graph, this side is called as the saturation region. Below this IB is equal to 0 is called as the cutoff region, and this part is called as the active region. So for low frequency analysis we use this graph also. We can determine from this the H parameters or vice versa. Here input characteristics of the transistor which we have seen. IB in microampere, this is input current is very less IB, which is in microampere, and this is input voltage VBE, base to emitter voltage, which is up to 0.3 or 0.7 volt depending upon type of transistor, whether it is silicon or germanium. And these three characteristics are shown for different value of output voltage VCE. This is the VCE, this is VCE1 which is less than VCE, and this is VCE2 which is greater than VCE. So from these characteristics you can also determine the input impedance HI, and from the output characteristics you can determine HO as well as HR. Here forward current gain you can determine HF. These are the parameters, and these are three configurations of the transistor shown in the table, and this is comparison is given here. Common base, common emitter, common collector. This is H11, that is HI. HI is the input impedance in ohms. In common base it is 21.6 ohm. Common emitter it is 1.1 kilo ohm, and common collector it is 1.1 kilo ohm. That is input impedance low frequency in terms of low frequency H parameter model, that is HI. This is HIB, this is HIE, this is HIC. Here H12, that means HR. HR is the reverse voltage gain, input voltage upon output voltage. This value in common base is 2.9 into 10 raised to minus 4, that is HRB. Here HRE 2.5 into 10 raised to minus 4, and here HRC, that is in case of voltage gain is nearly equal to 1. Either it may be a reverse voltage gain or it may be a forward voltage gain in case of common collector. Therefore its value is 1. Then H21 is the forward current gain, that is I output current upon input current. And in case of common base, this is minus 0.98, is nearly equal to alpha. Value of alpha HFB. HFB is approximately alpha, and alpha is the current gain in case of the common base, that is less than 1. And this is beta, C in case of beta. Beta is the HFB, HFE. Alpha is the HFB, beta is the HFE, that is equal to 50. Low frequency parameter HFE, and HFC, that is forward current gain in common collector, is minus 50, or sometimes it may be 51, because it is 1 plus beta, so it may be a 51. Then output conductance, that is HO or H22, its unit is microampere per volt. In common base, this HOB is 0.49, in common emitter HOE is 24, in common collector HOC is 25. And here this 1 upon HO, that is resistance, 1 upon conductance is nothing but the resistance. This is 2.4 into 10 raised to 3. It 40 into 10 raised to 3 and 40 into 10 raised to 3. This is the resistances, that is reciprocal of the HO. These are the various hybrid parameter variations. This is not important for you, so I skip this one. Now we will go for the analysis of the single stage amplifier circuit using hybrid parameter. For amplifying action, we connect an external load and signal source to the transistor and properly bias it. Let us determine some important quantities. Here, this is the transistor amplifier, this is the source resistance and source voltage, and here the load resistance, which is to be connected externally. And this transistor is now replaced by the low frequency H parameter model. And then we will analyze and calculate the various parameters like current gain, voltage gain, input impedance, output impedance of this transistor. In terms of low frequency, we will apply the low frequency signal over here. That Vs is the low frequency signal, Rs is the source resistance externally connected, RL is the load resistance externally connected. Let us consider this I1 is the input current and Vi is the input voltage. Rather than this source voltage, whatever is the actual input voltage goes to the amplifier, that is Vi, and Zi is the input impedance of the transistor amplifier. Zo is the output impedance of the transistor amplifier. Vo is the output voltage and Io is the output current. So this is the black box theory of the transistor for H parameter model. Now you can replace this box in terms of low frequency model. So low frequency model is this one. This is Hi, input impedance of a transistor. This is voltage source at the input, HR into V0 or HR into VO, and this is the current source, that is HF into input current II, and this is the output conductance HO. This is the output conductance HO, and this shows the output voltage here, load resistance. This load current flows through the load resistance and output current flows through this. This output current is divided into two parts. This current IO is divided into this current source HF into I1 plus this IO flowing through this conductance HO. So these two currents will be there, and here is the input current II and current flowing through the transistor source, that is voltage IB. Current flowing through this input impedance, and this source is the IB, that is base current, and Vi is the input voltage. Actual goes to the transistor. So this is the hybrid equivalent model of a transistor, single stage common. Any type of transistor you can take here. Either it may be common emitter, common base, or common collector. This is a general model general hybrid equivalent circuit for a transistor. This is the amplifier circuit in terms of transistor. You can use transistor here or box here and replace this transistor by this equivalent circuit. This is the equivalent circuit except the source resistance and voltage source and load resistance. These are connected externally and this is replaced by its equivalent H parameter model. Okay, then you can see here what we have to determine. You can go through this. I am showing close to this circuit. This is the equivalent model, hybrid model of a transistor which I have already shown. This is general model and all parameters are here. This is HI, this is HR into V0, VO, this is HF into I1, this is HO and output voltage V0, load resistance RL, load current IL, output current I0. These are in opposite direction. Here input current II and the base current IB, input voltage VI, source resistance RS and source voltage VS. Now from this we can determine first factor, that is current gain AEI. AEI is IL upon II, that is this output current IL, that is load current upon this input current II. But output current IL, load current IL is also equal to minus I0, minus I0, because this is in opposite direction. So you can write here IL upon II is equal to minus I0 upon II. Right? Now apply the Kirchhoff's law, current law to this loop here. I0 is equal to this HF into I1. You can see this is HF into I1 plus this HO into V0. This current I0 is divided into two parts. I0 is equal to HF into I1 plus HO into V0. HO is the conductance. So you can write this is equation. I0 is equal to HF into II plus HO into V0. Now V0 is equal to, again you can write here, V0 is equal to minus I0 into RL, because this current is flowing like this. So you can take this IL is equal to minus I0. So minus I0 into RL is also the same thing. So you can put here in place of this V0 minus I0 into RL. So here I0 is equal to HF into I1 minus HO into I0 into RL. Therefore, current gain is given by, you can take this I0 and this I0 common. So here 1 plus HO into RL. So this HF divided by 1 plus HO into RL. And minus sign is there for this current gain. So you can put here minus sign. That is AI is equal to minus HF upon 1 plus HO into RL. So this is the generalized current gain in terms of H parameter model or H parameters. This is the current gain of all type of configuration in terms of H parameter model. AI for common emitter will be equal to minus HFE upon 1 plus HOE into RL. Current gain for common collector is equal to minus HFC upon 1 plus HOC into RL. Current gain for common base is equal to minus HFB upon 1 plus HOB into RL. And if this HO into RL is very, very less than 1, then AI will be equal to minus HF. AI is the current gain, that is output current upon input current, and for common emitter it is equal to HFE. So you can write minus HFE. For common base it is minus HFB. For common collector it is minus HFC, like this. So this formula is used to calculate the current gain in terms of H parameter model. This is general for all three configuration. So in generalized way, it is determine all the parameters here. Next one is the input impedance. Input impedance ZI is given by VI upon II, input voltage upon II. Now you can write for the input circuit VI. From this diagram you can write VI is equal to HI into I1, this HI into II plus HR into V0, HR into II plus HR into V0. This is the input impedance here. once again, Vi is equal to this, Vi is equal to Hi into Ii plus this voltage source HR into V0. Now, what is the value of V0 here? Again, minus I0 into RL, because this IL will be equal to minus I0. So, minus I0 into RL is the V0. So, you can put here V0 is equal to minus I0 by RL. So, Zi minus I0 by RL you can put here, and you calculate Zi is equal to Vi upon Ii. So, this Vi upon Ii is equal to, here you will get Hi into Ii minus HR I0 into RL upon Ii. This Ii is here, and you can put this here. So, you will get here Hi plus HR, and you can replace this by this equation AI. HF upon 1 plus HO into RL here. So, you can put AI here. So, Zi is equal to Hi plus HR into AI into RL. Or if you write this AI in terms of above equation, this will be Zi is equal to Hi minus HF into HR into RL upon 1 plus HO into RL. So, this is the general form of input impedance, or you can say it is a formula for the input impedance in terms of the H parameters. That is, Zi is equal to Hi minus HF into HR into RL upon 1 plus HO into RL. Okay. So, dear friends, in next video, we will go for the other parameters like voltage gain and output impedance. Output impedance, current gain we have seen, input impedance we have calculated, and later on we will calculate voltage gain, output impedance. This you can see here. Tomorrow I will in the next video I will explain you all these things, and this is the analysis for all 4 parameters: voltage amplification, current amplification, and later on power gain. And this is the table, this is the all formulas which is shown here, that we will show in the next video, and later on I will tell something more about the H parameter model for the multi-stage cascading amplifier. Okay, so please go through the details. Thank you very much for listening this video. Thank you all.